Now, there are a whole range of chemical elements, and chemists have been able to put them into, in fact, a really super duper table for us. And we can look here at this table and we can look at the atoms and elements which have got mass numbers and atomic numbers. So if I look here at this, is Li is lithium. Lithium has got an atomic number of 3, so that tells me it's got 3 protons. Its mass number here, or its relative atomic mass, is 6.941. So we would round the relative atomic mass numbers up. So 6.941, we would call that 7. So we'd say lithium's got a atomic number of 3 and a mass number of 7. Another example here is beryllium, so an atomic number of 4, so it's got 4 protons. Mass number, so relative atomic mass of 9.0122, but a mass number of rounding that to the nearest whole number, mass number of 9. So in fact, beryllium's got 4 protons, it's got 9 protons and neutrons, so it's in fact got 5 neutrons altogether. Now the periodic table, if we look at the periodic table, it's actually arranged in a very, very clever way. So there are these groups across the top and periods down the side. So this here is a group. So they go vertically. This is a group, this is group 1. Over here, here's another group. All of these columns are all groups of the periodic table. Now, interestingly, when we look at the groups, so again, we'll just look at this at group 1 right here. Group 1, every single atom or every single element in group 1 has got 1 electron in its most outer shell. And the electrons in an outer shell of an atom are actually called the valence electrons of the atom. So those ones in the outer shell, the most outer shell electrons, are called the valence electrons. And all of these atoms, hydrogen and lithium and sodium and potassium, rubidium, cesium, francium, all of these elements have all got 1 electron in their most outer shell. If we look at group 2, all of these elements, beryllium, magnesium, calcium, strontium, barium, radium, all of these elements have got 2 electrons in their most outer shell. And this pattern continues across the periodic table. If we go all the way over to the other side, helium, neon, argon, krypton, radon, these are called noble gases. And all of the elements in this group, they've all got a full outer shell. So helium's got 2 electrons and they are in its first shell. It's a full first shell. Neon's got 10, 2 in the first shell, 8 in the second shell. So it's really stable with 8 in the second shell. Argon, it's 2 in the first shell, 8 in the second shell, and again it's actually got 8 in the third shell. So the third shell is stable with 8 electrons, so it's really happy to have a stable third shell. So all these atoms, all these elements in this group have got full stable outer shells, and all these groups are all the same. They've got the same number of electrons in their outer shells, and that's why they're put into these groups. Now, if we look at the periods of the periodic table, here's the period 1. So it's just hydrogen. That's not a very good drawing. It's hydrogen here, and over here is helium. So the elements in period 1 all have electrons only in their first shell, in their first outer shell. And if we look at the second group here, second period, sorry. So this period. I'll travel through this period, so these are the rows of the periodic table. This period, all the chemical elements in this period have electrons in their 2 most outer shells. So they've got 2 electrons in the first shell and then some number of electrons in the second shell. The next one down, so the third period here, all the chemical elements in this period all have electrons in their third outer shell. So the first shell of electrons is full, the second shell is full, and all these elements have got electrons in their third outer shell. And they're the periods. So the periodic table tells you all sorts of things about all of the chemical elements found all around the universe. So it tells you all about their atomic number, which tells you how many protons there are. and that normally tells you the number of electrons. You can figure out their mass number by rounding this relative atomic mass to the nearest whole number. It can also, of course, tell you how many electrons are in the most outer shell by looking at the group. And of course, it can tell you how many shells are actually in use, how many shells have electrons in them by looking at these periods. So 3 electron shells are used, 4 electron shells are used. So that is all about the periodic table, and that tells us an enormous amount about all of the chemical elements that exist.